core computing in-depth study Task3 project. And here is the list of our group members. So first of all, let's see the structure diagram of our architecture. As you can see that first of all, we have 3 Lambda functions and a Kafka cluster in a VPC and security group. And in addition, we have 2 tables in DynamoDB, another Lambda function, a API gateway, and a front-end page to show the dashboard of the transactions. So first of all, the Lambda function 1 acts as a producer to send purchase information to the first Kafka topic. As you can see, on top is the approval request topic. And the Lambda function 1 creates about 20 purchase requests. Each request contains the purchase ID, user ID, the item name, place, the amount of money, and the timestamp. And Lambda function 2 is triggered by the first topic. So when there is a message in the first topic, Lambda function 2 will consume that, and it checks when it receives an approval request, it uses the user ID inside the each approval request message to query the user table, which is here, the DynamoDB user table, and check whether current transaction is fraud or not. And afterwards, it attaches the approval tag to the request message and forwards that request message to the second topic, which is here the details topic. And Lambda function 3 acts as a consumer for this topic, detail topic, and for every incoming JSON message containing the details of a single purchase, LF3 will store the data into the DynamoDB, the second table here, for the front-end search, which is the here the S3 front-end page to call the API and then trigger the Lambda function 4 to query for the dashboard, query for the statistic data to show it on the dashboard. So this is the basics about our structure. And before that, let me first show the users of this AWS account. Here is the 4 users account for our group members. We use the net ID as our username. And before I show you the complete process of our tiny project, I'll first show you that this is the detail table, which is this one, which stores all the transactions data. So page for our CC detail table, which stores all the transactions data. As you can see, it's this table. And currently, we are at the last page of all the items, and as you can see that currently we have about 330 items in total. And now I'm going to hit the test button to trigger the Lambda function 1. As you can see that our Lambda function 1 will create about 50 transaction requests to trigger the the following functions in our project. So now I'm going to hit the test, and it's actually executed successfully. And then let's go back to this table. It might take some time, but as you can see that the number of items has been increased to about from 330 to currently 365 and 380, which is the number, which is 50, increased by 50. And as you can see that 50 is exactly the number of the request we've created in the Lambda function 1. So after this,
the demo of our dashboard. So for example, if you want to see the monthly billing statement for user ID 5, we click the search button and we can see that we have 1 accepted request and 5 rejected requests. We have defined the rules that if the amount is larger than 1,000 or the transaction's location is different from the user's locations, then it will be judged as a fraud transaction. So you can see we have only 1 approved transaction because the amount is less than 1,000 and the user's 5 is coming from Beijing. And now if we want to see the data of all transactions, you can see that we have 120 accepted requests and 260 rejected requests, which is total of 380 requests as we shown in the previous demo. So So this data is correct of our database, and that's the demo of our dashboard. Thanks.